So, why are we here? We're living in, I guess, a more multi-platform world these days. We're being asked to deploy or build apps that move across things like iOS, Android, Windows, sometimes even just back into things like WPF or Windows Forms if we're unlucky. Our bosses could be coming and asking us to build apps that target all these platforms or a subset. They could just be asking to build an app right now that is straight just for Android or for Windows. But you've got a sneaking suspicion that in 6 months' time, if you're successful, they're going to want the next platform. It could be a case that you've got a Windows Forms app, or WPF app, or even a website that has a sort of investment of C# code, and you want to leverage that across more and more platforms without having to build it all over again. So this is what this talks about. And also, C# is awesome. I don't know about you, but I love C#. I've been working with it since about 2001, just like .NET 1.1 days. It's been great, getting better and better. I don't know about you, I don't like the square brackets in Objective-C. There's too many of them. And Java is almost glacial in pace when it comes to C#. They've just got, in Java 8, lambdas, which if you kind of squint a little, they look a little like Link. But we got Link back in 2006, I think it was. So C#'s an awesome language. Async await, it came out about 2-3 years ago now. It's sort of baked into the framework, and it's going to be baked into things like JavaScript in about 2 years' time when the standards come around. So, cross-platform C#. This is what we're going to talk about today. And to cover it all, we're going to go on sort of these 3 steps. We're going to talk about some foundations, about how we can share C# across multiple platforms and the mechanics of it inside Visual Studio. We're going to look at the MVVM pattern, or model view model pattern, and about how we can use that and sort of the foundations of it and how it works and how it applies to different platforms. We're going to go into Xamarin because if you want to do C# across multiple platforms, this is the way to do it. We're going to look at both Xamarin Native and Xamarin Forms. And then we're going to dig into, if we've got some time, some advanced patterns in MVVM about how you can sort of orchestrate larger apps. If you're not just working in terms of mobile, but you're building sort of larger platform sort of tablet apps, then you might want to orchestrate larger apps and how we can do that. So my name is Nigel Sampson. I'm the apps lead at Marker Metro. We're an apps agency here in Auckland. I'm the project lead on Caliburn Micro, which is an MVVM framework. I inherited it from the guy who wrote it about 2 years ago. While this talk will use Caliburn, I'll try and keep the evangelizing to a low level and sort of talk about it at a general MVVM level while maybe highlighting some features that are Caliburn Micro specific. And I'm a Microsoft MVP in Windows Platform Dev. My email address is there as well as my Twitter account, so if you want to get a hold of me after the talk for questions, let's do it. So foundations. What do we want to do in terms of actually targeting all these platforms and how we do it? So normally before Xamarin or before things like Cordova, if we wanted to build multiple platform apps, we were building it 3 times. We're building it for iOS, we're building it for Android, we're building it for Windows. Often in their platform specifics, the appropriate languages, we weren't able to really leverage reuse and all. You might write the first one, it might take you 10 hours to do one feature, and then writing it again on the other platforms might take you maybe 3 hours because you've done it once already. But ongoing, your maintenance costs become terrible because if you fix a bug in one app, you're going to realize maybe that bug might be in the other app as well, might not be. You've got to go off and check. And so your maintenance costs really balloon as you go on. So it's not a nice thing to do, carry on this. And companies won't pay for this anymore. I guess the gold rush that came around in terms of the mobile days where you could charge 3 times X to build the app 3 times for different platforms, it's not there anymore. Companies won't pay for that. They want ways that they can save money on hitting multiple platforms. So this is what we want. We want shared view models, shared application services, shared business logic across all of our platforms, and then platform-specific features for iOS, for Android, and for Windows, and for any other platforms you're targeting. Why I think we should still have these platform-specific parts is that research has shown that apps that look and feel like they belong on that platform do better than ones that don't. So if you're building an Android app and you just copy and paste that UI into iOS or into Windows, users notice it. It doesn't look or feel like a native app to that platform, and you're not going to get as much conversion out of it. So we still want platform-specific features or platform-specific UI for each of these platforms, but we want shared view models and shared application services. But to do this, we need to share C# between projects, and there's across multiple platforms. And there's a few tools we can use to do that. Portable class libraries, shared projects, and shared files. I've got them in this order because they're the order I kind of like to work in. They've obviously all got their strengths and weaknesses, but I try to work with portable class libraries first. If they fail or don't meet the appropriate circumstances, work my way down this list. I'll start with the top and we'll work our way down about, I guess, why they're good, why they're bad. So portable class libraries are a project type in Visual Studio. You can file a new project, no worries, and it picks you up, gives you a list of platforms that you want to target. This covers things like .NET 4, .NET 4.5, Silverlight, Windows Phone Silverlight, Windows 8, Windows 10, Xamarin iOS, Xamarin Android, Xamarin Mac, and the like. What you can code in that portable class library is the subset or shared API across all of those platforms. You cannot write Windows-specific code in that portable class library unless all you've done is picked the Windows box. You can only write what's common across all of them, which is a good thing, in my opinion. It forces you to write platform-agnostic code, and I think that's a great strength of them. So if you wanted platform-specific behavior in there, how would you do it? Well, you can't. If you tried to write anything specific to one platform in there, the library won't compile, and you're basically stuffed. What you would do is work on things like dependency injection and version of control. Create an interface, like let's say we wanted to work with a camera, an iCamera service that then each platform implemented, iOS camera service, Windows camera service, and then injected it into that portable class library for that PCL to work. We'll go through some demos of this as well. So that's the best approach, in my opinion. It enforces platform agnosticity, and it still provides mechanisms for you to inject platform code into it via things like conversion of control and interfaces. But its weakness is the same thing. If you've got a class that's going to do a lot of platform stuff, then you're going to maybe be creating lots of interfaces, or it might be every second line might be a different sort of platform part, and you're going to find that you're just creating so much work for stuff that's really specific to a platform, and you end up sort of creating a bit of a mess and a bit of a dependency hell for yourself. So that's why portable class libraries are good, where they're bad. If that's the case, then you can work your way down to shared projects. So shared projects was a new project type that came out sort of around Windows 8.1. It was a solution to building universal apps in their Windows 8.1, Windows Phone 8.1 days. In this case, what it would create is a shared project and then two project heads. And then at compile time, the files would be copied from the shared project into each of the project heads. So we'll see this in a minute. What this is great for is that it means the actual file, the C# files, aren't shared at runtime. They're shared at compile time. So you can put platform-specific code in there. You just have to do things like use build directives to if-diff around it. This is pretty cool, but it can be kind of messy if you're doing anything that's very platform specific. You may have like if Android and not iOS but Windows as an if-diff, and it gets a little confusing every once in a while. But if you're trying to share massive swathes of code at compile time across multiple projects, that's the way to go. Its weakness, however, is that when you reference a shared project from a project head, is that it copies every file across. Essentially copy and pastes everything in that shared project, puts it into the project head. So if you've got a lot of files that might be specific to two of those projects, but not to the other three, then you've got to do a sort of file level if-diff, if not Android, if not Android, if not Android, etc. across every file, and it becomes a bit of a maintenance nightmare in that case. At which point you can shift back to sort of the old standard, which we all know and love, shared files. Go to one project, add existing file, add as link. That file's now on both projects, and you've got to do that sort of maintenance dance of making sure that you don't write stuff in one file, in that file that doesn't compile in both. So let's see this in action. Excuse the squeaky stage. You guys see that okay? Font size okay? Cool. So I've got this demo obviously already set up using portable class libraries. You can see this one here, it's saying it's portable already, but we'll go from file new as well. So file new project, we'll just quickly search for I want portable. I want a C# portable library. Call this port. This immediately gives us this dialog of what frameworks we want to target. And as you install more things into your Visual Studio, new things will highlight. So if base Visual Studio won't show things like Xamarin in there, it's only once you install the Xamarin framework onto your computer, you'll actually see this stuff. So you can sit here and say, well, actually, I don't want 4.6. I want to use 4.5. I want to target, don't want ASP.NET Core, but I want Phone 8.1. And there's gives you a few things done here as well. So because a lot of these frameworks are very, very similar, it'll tell you some rules like, well, actually, we're going to give you Silverlight 5 and Windows 8 for free because, well, they're the same as what you've already got, so you're not going to lose anything by doing so. And also some warnings here that if you do this, you won't be able to do it in Visual Studio 2010. So I'll just say, actually, what do we want on Xamarin now? Yes, and we want, yep, that'll do. So we'll go again. This, ooh, I hit the wrong button there. Anyway, so this gives us our portable class library. And we can always change later on in properties what we're targeting. So that means any framework, any app we're building that is one of those platforms can reference this portable class library. Anything that's not in that list, however, can't. So if we quickly jump back to my demo, we can see this in action. So I've got this app here called Hub. That's basically a very, 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 very small client into to GitHub. And this here, the main business logic for this app is a portable class library, targeting, obviously, all the things we want to do for this demo. And we reference it as we would any other project. So we just add reference, projects, and select it. Shared projects are a bit different. So if we just add one of those, we'll create a Visual C# project. And we'll just call this one shared test. So you can see it looks a little different. This thing doesn't have an output, right? So it has nothing much to it. It's basically a SH proj, which has a listing of what it holds in terms of files, but there's no properties page. It's really, really simple. So if we add let's quickly add a class to it. We can see here, and right now we can write anything we want in it because we're not referencing it from anywhere. But let's actually jump in and in our native Android app, add a reference. And you'll find that you find them not under projects, but obviously under shared projects, reference shared test. Put in there. So one thing Visual Studio added, so this is awesome if you're doing shared files or even shared projects as well. This is in Visual Studio 2013 as well. Is they've added this third drop down here. So this drop down gives you all the projects this file is in. So if it's a shared project, it's all projects that are referencing that shared project. And if you've got this file shared via add existing file, this will be all those files that it's added in. So what it means is if you're doing stuff like, because I just obviously added this to Android, and obviously you get IntelliSense for the compiler directives for the projects you've referenced, if Android, and the like. And so if you've got lots of platforms here, you can quickly just jump between the two projects, or 3 or 4, or in terms of Caliburn, I think there's one project that has 10. This file is in 10 different projects for the 10 different platforms, and you can quickly see what's what and what's not working properly. So those are, in my opinion, the best ways to share code between them. We'll start with portable class libraries. If they work the best for you, or if they don't work your way down through shared projects and then shared files. So that's how we're going to sort of, at the mechanics, share C#. It's a bit of a tongue twister. Let's get into some patterns. So MVVM is a pattern or a name that came out of the sort of the WPF days, but it's been around as an idea for quite a while. Martin Fowler first talked about it in this idea of presentation model. That link at the top is quite old, but it's still an awesome link about this idea of we want to separate the behavior of a view from the implementation of the view. And that's essentially what MVVM is trying to get as much behavior out of that view and put it into a view model. That way it's separate, it's nice, it's useful, and it can be shared across multiple platforms. And this is our basic architecture for MVVM. We have our view. It's going to be, in case of Windows, it'll be XAML. In iOS, it'll be a UI controller. We have our view model that's separate. View state is going back and forth between the two. So as we change the state in our view model will change its state to reflect that. And user interaction, and that's going to go back the other way as well. As the view model changes state, the view should change its state to reflect that as well. So, and what I mean by that is, if we type into a text box, that's view state going from the view to the view model. If data is being loaded from a database, that's view state going from the view model to the view. And behind that, we have our model. And that's everything else. That's your application services, your databases, your cloud, everything. So it's a bit out of proportion, but the model is most of it. And from there, we have unit tests. Because our view model is separate from our view, we can unit test it separately. And that's probably the best part about it. UI separation patterns, such as MVVM, MVC, MVP, we're not very good at naming these things, are we? Helps us create stuff that's separated. Because it's separated in the view, we can test it easier, we can maintain it easier, and because we're sharing it across multiple platforms, it's faster. Now, this came out, the idea of presentation model has been around for quite a while. MVVM, as the name, as I said, came out of WPF. And that's because XAML frameworks, they come with a lot of stuff that makes MVVM awesome. They come with binding. It's amazing once you get out of that sort of XAML area and you work in frameworks that don't have bindings, how much you miss it. Bindings are awesome and easy, and they make life a lot less tedious, I found. Simple bindings between view and view model, as I change this view, update this view model, as I change this view model, update this view, comes naturally to WPF, to any XAML framework, really. And it makes it a lot easier. Commands do the same thing. But we can do away with them. We don't need them to do MVVM. Notice in our diagram here, we don't mention binding, we don't mention commands. They aren't part of the pattern. They're part of the framework which enables the pattern to be better. So let's see what this looks like. Cool. So this app's going to be really simple. We're going to log into GitHub and we're going to search for repositories. It's nothing particularly complicated here. And this class here is the login view model. Now, it's called no-30 view model for a reason, but I'll get to that in a second. And it's a standard view model from kind of what you'd see if you're working in sort of WPF days. We're depending on two dependencies, fire and version control. We're depending on application navigation. So that's a kind of a platform dependency injected into this view model. We want to be able to navigate between pages in our app, and that's how we're going to do it. And we're dependent on authentication service. So that's an application service. I want to make sure that my credentials are valid against GitHub. We then have some background fields and some properties. Now, most of MVVM depends on iNotify property change, which is an interface built into Windows, and it's available on things like Xamarin as well. So you're still going to be using that. Now, this one here, this line here, we're not actually saying what we're notifying the property change of, and that's because we're using caller member name, which is an attribute that came out of .NET 4, I think. So, sorry, C# 5, my bad. Which means that I don't need to tell you its username. It can work it out from itself. And we've got another one here. We've got a property further down that's computing whether a login is possible right now. Basically, have you typed in a username? Have you typed in a password? And we're saying, as username changes, notify that can login may have changed as well. We've got password doing the same thing, except for a bug. We're explicitly saying that when password changes, username is changing and password's changing. That's wrong. Username isn't changing it. This should be, God damn. Can login. There we go. So this is one of the problems with things like notify property change patterns. You've got to be quite explicit about what's changing, and that before would have compiled fine, but you would have noticed if you were using that view model, as you changed your password, can login wouldn't have changed, or the view wouldn't have reflected that can login has changed. So be careful of that sort of stuff. We have our can login property, which is, as you can see, it's computed off username and password, which is why as username and password change, can login changes with it. We've got a simple message property and a login method, which basically says, check to see if our credentials are valid. If not, show a message to the user. Otherwise, navigate to repository search. So it's a nice, simple app. But we can do better than this. This is Visual Studio 2015. I've got C# 6, which brings a load of awesome features. And I want to use a library called Fody, and its extension property change.fody. So this is a library which examines your code and rewrites it at compile time to put those notify property changes in for us. And C# 6 makes our syntax a lot easier. So let's look at that. So this is the actual one that's being used. We have our constructor with our dependencies. As we did before, that hasn't changed. But username and password have become just simple auto properties. And that's because Fody at compile time is going to write that notify property change code into that property for us. We have can login, which looks a lot simpler because we're using the C# 6 feature of an inline property declaration. We don't need to do the whole gets and stuff. We just declare it as a lambda like that. Now this attribute here depends on, with something out of Fody, we're saying that can login depends on username and password. So when you rewire username and password, add in that dependency for can login. And we're using the C# 6 feature, name of. That means it's kind of like type of, but just returns username as a string. That means I don't have to have magic strings in my code, which if I do refactoring leads to not compile time errors, but runtime errors, which are often harder to find. Now login is pretty much the same. So let's quickly see this in action. I have a Windows 10 app here. And the ceremony isn't too much. We have an application which comes out of Caliburn. We're configuring view locator and view model locator, which are Caliburn-specific features around telling Caliburn where to go to find views and view models. Normally it can do this by convention, but because we're putting all our view models in a PCL that's shared across everywhere, we need to tell it where to look. The rest of it is pretty standard container configuration. I'm creating a container, registering my services, my navigation service, my authentication service, and the like, and I'm registering my view models. And a bit further down, I'm saying, when you launch, go to the login view. Nothing particularly crazy there. So, in my login view, this isn't particularly complicated. I've got no code behind in this, I don't think. Nope, pretty clean. We've got no logic or view logic in this at all. All of it's being pushed out to the view model. We have a text box here that's bound to username. The binding is two-way, and the update source triggers property change, which basically means update the view model on every key press, not just when the text box loses focus. We do the same thing for password, and we have a message attached, which is a Caliburn feature. Attach the login method to this button. That means when they click the button, we call the login method on the view model. What Caliburn also does is says, well, you want to call login. I'm going to look to see if there is a property called canLogin. Yep, there is. I'll bind it to it enabled on the button for you. So that lets us control the login flow until they've typed in everything. So a quick look at that in action. This is our login view. It's running on the Windows 10 phone emulator. Notice the login button is disabled because it's bound to canLogin. CanLogin is evaluating to false. Type my username. And as we key press here, the login button becomes enabled because that binding is updating the view model. That view model is notifying that back to the view that, hey, the canLogin property has changed. And suddenly the button becomes enabled. Login was successful. We get to the next page. Or if we just type, we get our error message. So that's nice and simple, works fine. And we can test this really quickly. So I'm using XUnit here. I'm quickly testing over different conditions of username and password that canLogin is correct. So I'm saying if both of them are null, that you can't log in. If one of them is username or empty string, etc. And then here I'm using mocks or interaction-based testing to say that if the authentication service, font size, returns true, then I would expect a call to be made to the navigation service. So I can independently and outside of any UI testing, test that on successful login we go to the right page. And this test is framework independent. So I'm testing behavior not based on whether it's running on Windows or iOS or Android. I can test it basically anywhere and outside of the UI, which makes it a lot faster. So that's sort of MVVM. MVVM at a basic level about how we kind of build it up, what our view models look like, and how they might look bound to a view. So there's a lot of really, really good MVVM frameworks out there in the cross-platform and Windows space. This is in alphabetical order, so it's just coincidence Caliburn's at the top. And they all have their strengths and weaknesses, and they all have different focuses. Caliburn Micro comes along with the ideas of being quite opinionated in terms of convention over configuration. MVVM Lite is a very foundational work in that it allows you to build on top of it with your own conventions. MVVM Cross is targeted at being cross-platform right from the get-go. Prism is one out of Microsoft that started back in the WPF days, but it's been taken over by a couple of guys, Brian Lagunas and Brian Noyes, and they're taking it cross-platform as well. And Reactive UI was written by Paul Betts, originally of GitHub at the time. And if you love reactive extensions, this is an awesome library. If you like building that sort of functional reactive programming method, take a look at Reactive UI. So we've got this idea of view models. We've got this idea of how to build them and architect them in a way that we can share them across multiple platforms. Now we actually want to build an app using them. This is where Xamarin comes in. So this isn't a Xamarin 101 talk. I'm going to obviously use it. We'll talk about it really quickly. But if you want to know more, we'll get into that later on. So what is Xamarin? It's a tool to build native apps on different platforms, specifically iOS, Android, and Mac. They have full API access. So what this means is any API that's available to an Apple developer or an Android developer is available to you as a C# developer using that platform. This isn't write once, run everywhere. You still have to know that platform. You know, if you want to write Xamarin apps on Android, you have to know about activities and services and intents and resources. All that stuff you'd have to know about as a Java developer for Android. You're just doing it in C#. Same thing for iOS. You're not getting away from storyboards and UI controllers. It's just you're writing them in C#. And because they're in C#, you can reference portable class libraries. And this is where we share our code. And because we're actually using the native APIs, we get native performance. We're not running an interop layer of using Xamarin's abstraction of an Android activity. We're actually using the underlying activity that Google writes for Android. So how does this work really, really quickly? For iOS, they use an ahead-of-time compiler. They take your app that you write, they compile it to IL, and then they take that IL, put it through, I think it's LLVM process, and turn that into a binary ARM native ARM binary that runs on your iOS app. It's virtually indistinguishable from something written in Xcode, except for the fact they've taken the parts of the mono runtime that you're using, you're referencing, and bundling them with your app in terms of, so if you're only using a subset of it, they'll take those parts and compile them, because it's native, so they only sort of bundle the parts you need. Java's currently a bit different, Android's currently a bit different. Because the security restrictions are a little less strict on Android, you can do a bit more in terms of frameworks. They actually bundle the mono runtime with your app. So your app gets compiled to IL, gets bundled with the mono runtime, and deployed as an APK to your phone or your device. At that point, mono runtime spins up, JIT compiles your IL, and it runs as it would normally. They are, I think, doing some beta programs around doing ahead-of-time compilation on Android, but it's, as I said, in beta process right now. The point is that it's a native app, it's using the native APIs, and it's the native platform. So this is kind of not even a 101, but a really quick intro. If you want to know more, check out the build talk by Miguel de Casa, who's one of the founders of Xamarin. That's a great video on the whole process. So if we're using Xamarin, what does the architecture look like? It looks pretty much the same as we talked about with our ideal architecture. And we've got C# the whole way up and down the stack, which is fantastic, because as I said, I love C#. So MVVM on Xamarin looks much the same. As I said, we're not going to be able to get away from using that platform, where we still have to know everything about how an iPhone works, how an Android works. This, as I said, isn't write once, one everywhere. So on iOS, our view is the view controller. It's kind of a weird, once you talk about your view controller being the view in MVVM, you kind of get a bit of pattern stuff. But the view controller accesses the native controls in the view. So for our intents and purposes, it's the view itself. In Android, it's the activities and fragments. These are the parts that access the native parts of the view. So for our intents and purposes, they are the view. Let's take a look at that. Oop. So, as I said, I've got my hub core here, my project, which has the view models and the application services written in a portable class library. And then in this project, I have my Windows 10 one with its separate login view and repository search view. And up here, we have the Android version. So this is essentially an Android app written in C#. We're referencing a lot of the Android namespaces. And obviously there's a bit of Java leaking in here, because it always does. And we're setting it up much as we did the other app. We're configuring our container. However, we're configuring it with a few different things. We've been having some network trouble on this device, so we've actually injected the no network authentication service, the no network repository service, so our demos work all the time. From here, we have our layout. And if you've done any Android work before, you'd recognize this. This is XAML. This is Android's answer to XAML, or layout in general. So it's an XML declaration, it's not XAML, that allows you to declare layout. It'll look really familiar if you've done any XAML. It's just that everything is slightly different enough just to confuse you. So we're using linear layout instead of stack panel, edit text instead of text box, button is still button. And that works fine, right? So this is essentially a UI declaration. And this is there is a designer here, and that's built by Xamarin. if you don't like it or it's not working properly, you can use the UI tools built in Android Studio, that Google produce. Because this XAML is exactly the same whether you're writing this in Android Java or Android Xamarin. There's nothing different about it. And we have our login activity. So this is actually inheriting a base activity. It's doing a little bit of work to find our view model, locate the view model for this view, but nothing particularly crazy. We're actually using one of the other cool C# question mark equals, which basically says if view or where is not null, call attach view. But the rest of the code is in here, which we'll get to in a second. So if we look at this in the demo, we have an Android emulator here. Now, Android emulators, if you sort of looked at Android development over the last 3-4 years, most of them tend to suck a lot. They're very, very slow and hard to work with. This one's a little better, but we'll get to that in a second. Xamarin released an Android emulator. I think it's called Xamarin Android Player, and it works on top of VirtualBox. It's a virtualization technology. This means if you're doing cross-platform and you're working with Windows, you've got your Windows emulators using Hyper-V, you've got your Android emulator using VirtualBox. They can't run at the same time, so one of them is going to take a performance hit. This one is written by Microsoft. Yep, it's an Android emulator written by Microsoft. It runs on Hyper-V. If you install Visual Studio 2015, you can pick it as an installation option. But if you're not working with 2015, you can download it as a standalone install. And it works. You can actually use it with Android Studio. So even if you're doing Java development, you can still use a Hyper-V-enabled Android emulator through this. So it's pretty cool. It's the best one I've seen in terms of performance so far, but it still has its weird bugs, because I think it got released about 3 months ago. One of which is if I Alt-tab away from this emulator, the keyboard input gets corrupted. So watch out if I do that. Just need to use the taskbar. So this is our layout, our login layout, using the login activity. And it works pretty much just the same. As you can see there, the login button changed its enabled state based on the state, and we get it across into our repository search. Now, as I said, XAML frameworks help you with MVVM with things like bindings and commands. Xamarin out of the box doesn't help you in any way, shape, or form. So we've got to do a bit more sort of work ourselves. Some MVVM frameworks build in their own binding systems to deal with this, but I've chosen to sort of show you what it looks like if you're not using any binding subsystem. So we're going to sort of manually wire up our view to our view model. So the first thing we do is call findViewById and get our username and password text boxes. And we'll get the sign-in button as well, and the feedback message. So we've now got access to all our 4 controls. This is pretty much what you'd see in normal code bind. We're just getting access to those controls. I'm attaching to the button click event, and I'm saying, when you get clicked, call viewModel.login. And I'm wiring up this lambda to both the text change of username and password. And I'm saying, update the view model when that text changes, and update the button enabled based on can login. So I'm kind of doing that manual wiring for us. And on the last one, I'm doing a view model on changed. So I'm saying when the message property changes on the view model, update the feedback text to reflect that. So this is manual wiring, and is a bit more awkward, but you can get away with it, and it means you get a bit more explicit control. There are, as I said, some MVVM frameworks do have bindings, and they work with no worries. And a quick look at the repository search activity. So if we quickly switch back to this, I want to search for MVVM. We get some libraries out of GitHub, or in this case, my fake GitHub. We'll quickly look at that activity. It's a lot simpler because we don't have as much UI. We're basically finding our repository list and giving it an adapter An adapter is how you, in Android, do sort of binding to a list. Oop. And in this case, we're doing some work to hunt down that search view inside the header and wire it up to, on the query text submit, call view model search. And our repository search view model is really, really simple. It depends on a repository service. It has a bindable collection of results. When search comes in, we do a search for repositories, clear out the current results, put in the new results. So again, this is separate from your platform. You can unit test it, no worries at all. And I'll quickly look at the repository adapter, inherits from bound adapter, and does some work to basically create the view for each list item and set some properties. So in this case, I'm inflating the out-of-the-box layout simple list item 2, finding text 1 and text 2, setting the repository name and the owner login, which is why we get a sort of out-of-the-box look and feel like this. There are some other libraries out there to help you, which I won't go into now because we're running quickly on time. But I would look into a library called Cheeseknife, which is a really silly name. But there is an out-of-the-box library for Android called Butterknife. And what this lets you do is append properties in your activity and have them auto-populated from your view. So I'll quickly show you what that might look like if we want to do this the whole way. We would say private edit text username, which is, we use a attribute from Cheeseknife called inject view. And we want to get that resource ID. Stick that there. So and then we go Cheeseknife inject this. So what that'll do is rather than us going to call find view by ID, it will go off, look for all those properties, inject into that username the property, the text box instead. And you can also do things like that's not the right one, but it'll do. So if that was the idea of our button, basically means wire up this event to that button's click, and we're away. So libraries like Cheeseknife or Butterknife can help you reduce some of the ceremony or write in your own manual binding if you're doing it that way. So just quickly get rid of all that. So that's how we do MVVM at a sort of cross-platform level. We have our view models shared across multiple platforms, and on libraries that use bindings, we can use them and support them, no worries. And on ones that don't, we can sort of manually do it ourselves. But we're still writing independent apps or independent mobile apps for each platform, which if you're targeting consumer-facing apps, you're writing for the stores, I think that's still the best approach. You're able to get pixel-perfect design, pixel-perfect animation that make it appropriate for that platform. But a lot of the time, we're building enterprise apps. We're targeting internally, just to within our clients, but we still, in our companies, sorry. But we still want to target multiple platforms because it's bring your own device. So wouldn't it be cool if there was a way to solve this problem? And all problems can be solved with another level of abstraction. So this is Xamarin Forms. We're going to abstract the UI layer. We're going to have a Xamarin Forms button, which abstracts the idea of button over all of the platforms. Yeah. Most of the problems, anyway. So how does this look? We have shared views. We have shared view models, and we have shared application services. We've still got some colored boxes there because we're never going to get away from the fact we're on different platforms. There's always going to be platform-specific code in there somewhere. If you're accessing the camera in different ways, you're going to have to write the camera access code for those different platforms. You're not going to get away from that. But we want to try and share as much as we can. We want to share those views. So let's take a look at this. Cool. So I have Xamarin Forms up here. In this case, we've got another portable class library. I've called this one Hub Forms Core. And this one actually has views in it. And that's XAML, sort of, which we'll get to. We have our Forms application, and this code should look familiar again. We're configuring our container, but we're configured it in the PCL, so we don't have to configure it in both of our other platforms. And we have our login view. If you're astute, you'll notice that's not XAML. That looks like XAML, but it's Xamarin Forms XAML, which is just enough to make you a bit more complicated. I talked to some of the Xamarin Forms guys, and this is intentional. They aren't supporting the full XAML sort of spec, so they made it different. You're not going to be trying tricked into thinking this is actual XAML and do something that you normally could do. This is Xamarin Forms XAML. So stack layout, stack panel, entry, text box. Button is still button, because frame is border. There are references out there to help you with this stuff. It's just a bit different. But it supports binding. Yay, we've got binding back. It supports, obviously, as Caliburn supports see a message attach. So all this stuff works as you'd kind of expect. We've now got a shared view we're going to use across multiple platforms. So the actual host app looks remarkably skinny. The activity, we only have one activity now. We've got our main activity, and this is going to host everything internally. If we look at the code for this, we're basically initializing Xamarin Forms and loading the application. If I look at the Windows Phone version of this, we have one view, main view, and inside that, awfully similar code. So we're trying to get everything out of the shells, or the heads in this case, and stick them in that Forms core project, which means it's shared across every platform. So let's take a look at that at work. Should we just jump back to the... Doesn't look as good, but it works. So thinking. There we go. Right. So this is abstraction. Xamarin Forms is doing the work of taking that stack layout, that entry, everything in XAML, and turning it into platform-specific UI. So we're still not doing an abstraction in terms of performance, because that's a native button, a native entry, I think it's edit text, except that we're doing it at a higher level in terms of declaration. The way this works, if you want to look under the covers, is this concept of renderers. It takes a button, and on each platform there is a button renderer, which turns that button into, say, a UI button on iOS or a standard XAML button or anything like that. So how do we do platform-specific stuff in this case? Plugins and interfaces. So a place I'd really recommend going is that URL. Rather than having to write a lot, as I said, those colored dots we saw on that diagram, they provide plugins or interfaces for most of the native frameworks that you'd want. If you want to access things like the camera, contacts, network state, pop message dialogues, they're out of the box. They provide, here's a plugin, you can get them via NuGet or the Xamarin Component Store. And they allow you to inject that stuff without having to write it yourself. Most of these plugins work in both Xamarin Native and Xamarin Forms. So they work all the time if you're working with Xamarin, which is awesome. So let's quickly get into some advanced patterns. If you're building something that's not just a quickly 3-4 wizard app, but building something that might be working on the tablet, iOS, Android, or Windows, and what we can do about how we can architect these apps in better ways. Now, we're all familiar when we build UI layers around sharing parts of our UI. In XAML, we call this user controls, right? We go, hey, we're going to use this UI in 4 different parts of our app. Let's break that out into a user control and share that everywhere we need to. We should be doing that with our view models. And a great example I think of this is Visual Studio. So Visual Studio, when I kind of build something similar to this, we have our shell view model. This kind of represents our window, and its sole responsibility should be to manage tabs. It shouldn't do anything else. It shouldn't handle document editing or anything like that. All it should do is manage windows and tabs. In those tabs, we should have separate view models. We may have a document view model, we may have properties view models, we may have designer view models, and all these view models have their own views. But they all have their own responsibilities, and we compose them together in order to build a better application. This is, I guess, just more of a performance tip. If it doesn't involve changing the UI, it should not be on the UI thread. Most performance problems happen in these sorts of apps when we're working with code on the UI thread. Get it off that UI thread. It's just a performance tip. And when we're architecting our apps this way, when we're breaking them out into multiple view models, when we've got 6, 7, 8 view models representing a single screen, we need ways to talk together, for them to talk to each other that don't involve tight coupling. We don't want all these things to reference each other. We don't want those tabs in this diagram to know about the shell. We want the tabs to work independently. We want the shell to know about tabs because that's its job, but we shouldn't have the tabs kind of depend on the fact there's a shell there. We can do this through patterns like event aggregation, messenger, they're often called, and this reduces the coupling. So in this case, our tabs talk to the event aggregator talks to the shell view model. We can look at that right now. So I have another universal app, kind of mocking this whole Visual Studio thing. Not mocking, fake one. Call it Universal Studio local machine. So we'll quickly spin this up. Simple plus button over here. Create documents. We can switch between them. Close certain ones. We can open properties about that document. Quickly change the name of this thing. Close that, changes that property. And because I didn't code this properly, you can actually open up properties of properties and change that. But the idea works. And the thing is, this builds on top of each other. So how does this kind of work? First, we have this idea of a shell view model. In this case, we're inheriting it from an out-of-the-box class inside Caliburn, which is conductor of tab view model collection 1 active. What that basically means is this shell is going to be a collection of tabs, and only one of them will be active at one time. We're going to depend on the event aggregator, and on activation we're going to subscribe to it, and on deactivation we're going to unsubscribe to it, just for hygiene really. And up here we're going to inherit 2 interfaces. I handle close tab message, and I handle show properties message. And we have the implementations of them down here. So on handle show properties, we call activate item new properties view model. So we're instancing a new tab, and we're adding it to the collection and saying activate it, which basically means focus on it. On new document, we're just saying create a new document view model. And close does the things of if we're closing everything else, or if we're just closing this one, and we're calling deactivate to close that tab. the true there is close, as opposed to just deactivate it. And the UI for this looks really simple. We don't know anything about tabs in this UI, sorry, anything about what's in those tabs. We simply have a pivot control. We have, in our header, we're creating a menu flyout. And our item template for this pivot simply uses a feature called in Calibre, and it says, for this view model, go find the view. So this doesn't care whether it's a document view model or a properties view model. It goes off and finds the appropriate view. In this case, we have our document view and our properties view over here. Now, our document view doesn't have much in it besides some text, some lorem ipsum. But it inherits tab view model. And tab view model has some properties, some methods, sorry. Close all but this, and show properties. These push messages onto the event aggregator, which the shell view model can listen to. This is obviously a pretty simple demo, but the idea is that these tabs don't know about the shell. All they know about is when they want to close, they push a message onto the event aggregator, and something out there is going to handle it for me, which is pretty cool. So when you're building larger scale apps, I've seen some where you're building 6, 7, 8 view models composing one screen. You can use the event aggregator to message between them quite nicely. This leads into a bit more of an advanced thing, but these days functional programming is coming back in quite a big way. F# as a .NET language is becoming really popular. F# works really well with Xamarin. You can build an entire iOS app in F#. No worries. And it lends itself to MVVM really well. There's this idea of, and it's a great talk there, awesome talk, about this idea of functional core imperative shell. Functional programming has this idea of lack of state, of everything being immutable. View models by nature are mutable because they represent the view, and the view changes. So this idea of having all your imperative code, all the stuff that changes, being in your view model, and that references functional core, this idea of immutable services ladder up, works really, really well. So I'd recommend that talk, even if you're not kind of into functional programming, but this idea about how to use functional concerns like immutability and pure functions, and how to wrap them up in imperative parts. So to wrap up, because we're quickly running out of time, using the MVVM pattern in Xamarin, we can separate our view behavior from our view. We can put it in classes called view models that are unit testable, maintainable, and shareable across dozens of platforms. In theory, these view models could work across 10 to 12 different platforms, from Windows Forms, WPF, Silverlight, Windows Phone 8.1, Windows 10, Windows 8.1, iOS, Android, Mac. There was nothing in those view models that stopped them working on those platforms. And because of that, using tools like Xamarin, we can do that. And we've got patterns to sort of build on top of that to architect awesome apps. So I didn't get into everything in this demo. There's obviously that repository search and some other frameworks and other platforms in there as well. So the source code for all of this is up there. I don't think we've got time for questions. We've got like one question. Sorry, we've got time for one question. Otherwise, I'll be around after this to talk. Cool. There are some other sessions around these sorts of subjects. The adaptive UX and JavaScript talks were yesterday, but the JavaScript talk is essentially this, but using Cordova. So if you're more of a web person, then that's a great one to watch online later on. There's also some great stuff around taking these and designing them for making them better and look cool. A lot of this is also talked about in resources online. Channel 9 and the Virtual Academy have a lot of these sorts of things. And complete session evaluation to win. And we always depend on them for good scores. So, thank you.